discussing 10 question only, and we have left it because lack of time. So now we continue with that 10th question. What is it? We have to show this function is 1, 1 and onto or not. Okay, let's start with it. We have taken f of x1 equal to f of x2 and we have written this function. Now let's take cross multiplication of it. Why? Because we want to solve it for x1 and x2. So this one. Now open these brackets. x1, x2. Now this and here this minus 3x1. Now minus 2x2 minus plus 6. Similar way x1, x2. Now minus 3x2 minus 2x1 and minus 2 3s are plus 6. Now from both sides x1, x2 cancel. Plus 6 cancel. Now shift x1 on this side. So minus 3x1 plus 2x1 and 2x2 on this side. So minus 3x2 plus 2x2. So what you get? Minus x1 equal to minus x2. That means you can say x1 equal to x2. So from this first part we have proved that it is 1, 1 function. Now let's come to onto. We are taking y equal to x minus 2 upon x minus 3. Now let's start cross multiplication. So xy minus 3y equal to x minus 2. Now what to do? We have to make equation for x. So combine x together. Xy minus x equal to 3y minus 2. Now among these two, I have taken x common. So 3y minus 2. So x equal to 3y minus 2 upon y minus 1. Now the same thing we have to put up here. So x minus 2 upon x minus 3. So I can write 3y minus 2. We have to put up on place of x. Upon y minus 1 minus 2 upon 3y minus 2 upon y minus 1 minus 3. Now what is our next step? Take LCM. So let's take LCM. 3y minus 2. Now y minus 1 on this side. So minus 2 into y minus 1. Denominator is same in both, so we can cancel it. 3 into y minus 1. So now open your brackets. So what you will get? I think this one is clear to you, so I rough it. How to prove 1, 1. Okay, now let's come to this part. 3y minus 2 minus 2y plus 2 upon 3y minus 2 minus 3y minus plus 3. So here what is the cancelled term? This, and here this. So 3y minus 2y is y and 3 minus 2 is 1. So you get y. So from this we can say it is onto also. So first we have taken x1, x2 same and we prove that x1 equal to f of x1 equal to f of x2 we have taken and we prove x1, x2 same. Here we have taken y equal to function. We make equation for x. We have put up in function and we derive it is equal to y. So from this two part you can say this function is 1, 1 also and onto also. So if a function is 1, 1 and onto, you can say it is a bijective function. Okay, after bijection, I think so many questions we have discussed, each and every question almost. So it's more clear to you. Now last two questions is MCQ. So let's do it. 11th question. Your 11th question is given function from R to R and fx equal to x raised to 4. Now you have given 4 options. First is f is 1, 1 and onto. Second many 1 and onto. Third 1, 1 but not onto. And fourth neither 1, 1 nor onto. And the same way your 12th question also given, which is the correct option that we have to choose. Okay, let's start with first 1, 1 and onto. You already know for square power, 3 power or 4 power we have already discussed so many questions. Let's come to the 4 power. Let's start with minus 2. Minus 2 is 4 power. What do you get? 16. Similar way, minus 2. Now I take plus 2 is 4 power. So again 16. Minus 1 is 4 power. So will be 1. And plus 1 is 4 power. Also 1. So what is it? For two different questions, same answer. So function is not 1 1. Okay, not 1 1. See, it is MCQ. So no need to go by definition. You can go by the example, because in MCQ you have to choose the shortest way. How can we complete it fast? Okay, now we have to write a range of function. Now you can check. Range must be all the terms with 4 power only and positive. Because of even power, all negative numbers became positive. So range must be your r plus union 0, which is not equal to r. So function is not on 2. It is not 1 1, not on 2. So which is your option? Option number D, neither 1 1 nor on 2. So answer is option D. You can check it. This is the easiest and shortest way, so you have to follow it. Okay, read next question. Fx equal to 3x, and you have to check, is it a 1 1 and on 2 or not? And your options are given, which is again in the same format. That first option is 1 1 and on 2, second many 1 and on 2, third one is f is 1 1 but not on 2, and neither 1 1 nor on 2. Here again we solve it by the example only. Let's start with minus 2. So 3 into minus 2, 3 2s are minus 6. Minus 1. So 3 into minus 1 is minus 3. Now 0. So 3 into 0 will be 0. Now 1. 3 into 1 will be 3. Now 2. So 3 into 2 will be 6. You can check. For a different question, different answer. And all, suppose we have taken negative integers, we are getting negative answer, positive, then positive 0. That way, means you get one question, single answer means 1 1. And range of function is all real numbers, because if we choose real number, then root 2. Then you get 3 root 2, that way. So all real numbers. So therefore it is on 2 also. So your option is option number A. It is 1 1 and on 2, both 1. So we have discussed exercise 1.2 full exercise, and we have discussed each and every question of 1.1 and 1.2. So now you have to complete your exercise 1.1 and 1.2 both one in your notebook, and we continue with our next topic. Okay, what is our next topic? In next topic, composite function. Now what is composite function? Okay, first we start. What do you mean by composite function or composition of a function? See, suppose we take one example in your class. Suppose you are 10 students or 60 students. So we have allotted a roll number. Suppose student A, whose roll number is 1, student B, whose roll number is 2, student C, whose roll number is 3, student D, whose roll number is 4, and up to so on. That way we have allotted a roll number. Okay, now this is your one function. First function F, that with every student one allotted roll number. Now when you go for exam, right? So you are writing your roll number. This name is not mentioned on your supplementary, only roll number is written. Okay. Now according to roll number, the teacher will check your supplementary, and with that maybe 50 marks test, so she will give you marks that way, right? So this is your another function, which is first function, that with the name of student roll number is mentioned. This is your one function. Now with the roll number marks is written, that is your second function. But now I want with name your marks. When I want to write in your report card, what I want, that suppose A get 45 marks, that I write, B get 20 marks, that I want, C get 40 marks. So I combine these two functions and I make it GOF. What is it? I have combined F and G both. So now what I get? With A 45 marks, with B 20 marks, with C 40 marks. So this one is skipped. right? So this is called composition of a function. Okay, now we take one example. Composition I have already explained you by this example. That way you can consider so many examples. Suppose I mention function f a to b, another function g b to c. Then I can mention g over f a to c. That way we can mention. Okay, let's understand by the diagram, Venn diagram. So how can we mention the composite function? That I show you first. Suppose you have given one set A, another set B, and third set C. We consider the same example. In here we have written your names. This is your function f a to b, and with that I have mentioned here your roll numbers, right? Now another function from b to c, that is your function g, in which I show your marks. So 45, 20, 40, 30, 35 and so on. So what I mentioned, from A to 1, 1 to 45, B to 2, 2 to 20, C 3, 3 and 40. 4 roll number, marks is 30. 5 roll number, marks is 35. So this function which I mentioned directly with A, B, C, D, E, that is called your G over F. Means I have combined function F and G, and it is written as a G O F. Okay, how I have written G O F? That way you can write F O G also. So, but where this function exists, that is the main thing. So when G over F is exists, if your range of F, what is it? Range of F is a subset of domain of G. Range of F is a subset of domain of G, then only G over F will exist. And what about F over G? Range of G is a subset of domain of F. Then we can say that your F over G exists. So we have already discussed what is composite functions. Okay, now let's revise what we learned in this chapter, because this chapter is quite long and so many things which one you have to remember. So in first part we have discussed type of relations. So which type of relations you learn in your first exercise? That 3 type of relation: reflexive, symmetric and transitive, and then 2 more, which is empty relation and universal. But as far as sums concerned, we have to remember the 3 relations, which is reflexive, symmetric and transitive. And if any relation satisfy all 3 properties, then you can say it is which type of relation? Equivalence relation. Okay, that was your first exercise 1.1. In second exercise, we learned what is 1, 1 and onto functions. 4 types we learned: 1, 1, not 1, 1, onto, not onto. What we learn in 1, 1 and onto? We discussed for 1, 1 and onto that if single question, you get the single answer, or you can say injective function or 1, 1. Then you get it is 1, 1 function. What is not 1, 1? Means for 2 or more than 2. Another questions, you are getting the same answer. Then you can say it is many 1 function. Now we on to what we learned, that if a range and codomain are same, then function is said to be onto. And if a range and codomain are different, then you can say it is not onto. If a function is 1, 1 and onto both, then you can say it is a bijective function. And what is the new names for it? 1, 1 is injective, onto is surjective, and if a function is injective, surjective both, then you can say it is bijective. Bijective means both. 1, 1 also, onto also. And our third topic, what we learned for third part, composition of, I have written only composite function, but the composition of a function. Composition means what? We are combining more than 1 function. So we have taken 2 functions over here, that is f and g. What I explained you? I have given one simple example. Suppose in a class A, B, C, D, E. That way all the students are there. We have allotted our roll number 1, 2, 3, 4, 5 up to so on for it. And in exam, so this is your first function. In exam, suppose roll number 1 secure 45 marks, 2 get 20, 3 get 40, that way. So first is name and roll number, that is your first function. Now roll number and marks, that is your second function. So what I want to know, that with the name of the students, I want to know the marks. So what I do, I have combined F and another function G, and I make it F over G. Now what I told you, that range of F is a subset of domain of G. Now let's check. What is the range? Range always lies in codomain. So what is your codomain here? 1, 2, 3, 4, 5, which is roll number. And for the second function, what is your domain? That roll number only. So here range and codomain are same. So we can say, if a range of a first function is a subset of a second, then its domain, then you can say range of F means range lies here. This is only your domain of G. So range and domain is same. That's why G over F exists. Same way what we learned for F over G, that range of G, second function's range lies in the domain of first function, then F over G will exist. So I think what is the composition of a function is more clear to you. In our next class, we will start the example of composite functions. So for today, thank you very much.